Good morning, all. Today we are going to discuss the topic design of lap winding and wave winding in DC machine in the subject design of electrical apparatus in first unit. So, in first unit, design of lap winding and wave winding is there. So, we are going to discuss the topic design of lap winding and wave winding now. So, it is armature winding design. The armature winding of DC machine, there are two types of winding, lap winding and wave winding. And also another classification is simplex winding or multiplex winding. In a lap winding and wave winding, number of parallel paths will be differing. In a lap winding, the number of parallel paths is equal to number of poles. In a wave winding, number of parallel paths will be equal to 2 always. And lap winding will be used in high voltage applications and high capacity machines. The wave winding is used in small and medium sized machines. And duplex winding and multiplex winding or multiplex winding will depends upon the number of parallel paths only. Suppose if the number of parallel paths is 2 times of simplex lap winding or simplex wave winding, that will be represented as duplex lap winding or duplex wave winding. Suppose if the number of parallel paths is 3 times that of simplex lap winding and wave winding, then that particular winding will be represented as triplex winding. So like that, number of parallel paths will decide the winding, whether it is simplex winding or multiplex winding. So now we are going to take only simplex lap winding design and simplex wave winding design. So as we know, the number of parallel paths is equal to number of poles in a lap winding, and in wave winding the number of parallel paths is always 2. And so the current through a conductor, I is the armature current and P is the number of poles. So current per parallel path is IA by P in a lap winding, and it is IA by 2 in a lap winding. So like that, voltage rating will be of P by 2 times that of the wave winding in a lap winding, and the cross sectional area of the conductor is 2 by P times of that of the wave winding. And but the volume of copper will be same in both lap winding and wave winding. But in lap winding, the cost will be lower because it is having many number of parallel paths, and it is in area required for insulation will be more, and so the cost of lap winding will be more as compared to that of the wave winding. Another factor is equalizer connections have to be used in lap winding because there are so many parallel paths. But in wave winding, the parallel paths are only 2, so no need of any equalizer connection to compensate for the circulating currents if any produced in the windings of different parallel paths. Okay. And here the short pitch coils can be made in, and it is also easier, but short pitch cannot be used in wave winding. As I already mentioned, the lap winding is used for large capacity machine, and wave winding is used in small and medium capacity machine. And before getting into the armature winding design, we will discuss some of the important terminologies used in armature winding. So as you know, conductor is the active length of copper or aluminum wire in the slot. Overhang is not considered as conductor, okay, or end ring is not considered as conductor. Single turn consists of 2 conductors, bottom and top conductor of a single turn coil. Coil turn will be consist of 2 number of conductors. One is top conductor and another one is bottom conductor. Top conductor is placed in one slot and bottom conductor will be placed one full pitch or short pitch apart from the top conductor. A coil consists of number of turns. A coil may be single turn coil. If it is single turn coil, only 2 conductors will be there. If it is multi-turn coil, depends upon the number of turns. The coil turns will be different. Coil side and conductor actually will be the same. coil side or conductor will be the same. Upper coil side and the lower coil side will be the same. Overhang or end ring is to connect two conductors to make a single turn. Actually, overhang portion will not be in the armature portion. It will be out of the armature portion, and it is not going to take part in the energy conversion process too. Coil span is the distance between two coil sides of a coil. For a full pitch coil, it will be 180 degree. For a short pitch coil, it will be less than 180 degree. And so it is given full pitch coil. It is equal to pole pitch. One pole pitch is 180 degree electrical. So that is full pitch coil. Short pitch coil means it is less than one pole pitch, and so it is less than 180 degree. Single layer winding and double layer winding is in a slot if when the coil sides are arranged in a single layer in a slot. So if only one top coil side is there in one particular slot, it is single layer winding. If two top coil sides are placed in one slot, that will be represented as double layer winding. So number of coil sides arranged in a particular slot is represented as layer. So it is a single layer winding, two layer winding, and it is three layer winding, and so on. So these are the terminologies in armature winding: conductor, turn, coil, coil side, overhang, coil pitch, full pitch coil, short pitch coil, single layer winding, and double layer winding. So next we are going to discuss about different terms used in winding design. So first one is the pitch. Actually, we know what is slot pitch and pole pitch. Because we discussed in the previous portions of this particular unit. So now we are going to discuss the pitch related to the winding. Previously we have discussed the pitch related to the core of the machine, that is pole pitch, slot pitch and pole pitch we have discussed. Now we are going to discuss the winding pitch. The pitch of the winding we are going to discuss. The first one is the back pitch. So it is the distance between top and bottom coil side of a coil. So we will be solving a problem later. So we are calculating the back pitch and back pitch for lap winding and wave winding in terms of the number of slots. Okay. So it is difference between odd and even number, because in armature winding the top coil and bottom coil sides will be numbered in odd number and even number. Suppose top coil is numbered in odd numbers, bottom coil side will be numbered in even number. You can make it reverse also, but whatever it may be. So the usual convention is top coil sides will be numbered in odd number, bottom coil sides will be numbered in even number. So the difference between odd number and even number will always be odd number. So the back pitch always be in odd number. Front pitch, YF. YF is the front pitch. So it is the distance between two coil sides connected to the same commutator segment. So it is the distance between two coil sides connected to the same commutator segment. So it is also calculated in terms of slots only. Winding pitch. Next is the winding pitch. It is the distance between starts of two consecutive coils measured in terms of coil sides. Distance between the start of two consecutive coils. Okay. And it is YB minus YF for lap winding and YB plus YF for wave winding. So it is the distance between starts of two consecutive coils. Next one is the commutator pitch. So it is the distance between two commutator segments to which the two ends, start and finish of a coil, are connected. Okay, distance between two commutator segments to which two ends of a coil are connected. So for lap winding it is always 1. For wave winding we are calculating in terms of slots. So now let us see how lap winding and wave winding are represented. See here, so this is the dark lines represents the top side of coil, top coil side, and dotted line is the bottom coil side. So this is numbered in odd number. Top coil sides are numbered in odd number 1, 3, 5 and so on. This 2, 4, 6, 8 and so on are even numbered bottom side, bottom coil sides. So this dark line represents start of a winding. So it is S1, start of a coil. Okay, S1, S2, S3 and so on. And this is finish of a coil. F1, F2 and so on are finish of a coil. And so now all the pitches what we have just discussed we can see here. So front pitch is the, what is front pitch here? As per definition, the front pitch, uh, back pitch. Let us take back pitch first. So it is the distance between top and bottom coil side of a coil. Distance between top and bottom coil sides of a coil. So let us take, this is the top coil of a first coil. So it is the distance between S1 and F1. Start and finish of a coil. Okay, so it is the distance between S1 and F1. So back pitch is the distance between S1 and F1. It is actually the lap winding. And in wave winding, so this is S1, start of a coil, and finish of a coil is here. So the distance between start and finish of a coil is back pitch. So it is 8 minus 1, 7 in wave winding. So in lap winding it is 8 minus 1, 7. So back pitch is 8 minus 1, 7 in both cases. So it is back pitch is 7. So back pitch is the difference between, distance between top and bottom coil side of a coil. Do you understand? And next pitch is the front pitch. It is the distance between two coil sides connected to the same commutator segment. Distance between two coil sides connected in same commutator segment. See here, front pitch is the distance between two coil sides connected to the same commutator segment. Okay. So distance between, so it is one commutator segment. Okay. You take this second commutator segment. Okay. So this is the second commutator segment. So here two ends, start and finish of a coil are connected. Okay. So distance between start and finish of a coil connected to the same commutator segment. So it is 8 minus 3 in case of lap winding. And if you take one of the commutator segments, say here, let us take this commutator segment number 8. So here two coil sides are connected. So that is 15 and 8, start and finish of a coil connected to the same commutator segment. So that is the front pitch. So front pitch is 15 minus 8. So 15 minus 8 is 7. And here with respect to the lap winding it is 8 minus 3 is 5. So 5 for lap winding and 7 for wave winding. So front pitch is 5 for lap winding and 7 for wave winding. And winding pitch is difference between back pitch and front pitch and addition of back pitch and front pitch for wave winding. So already we have calculated back pitch and front pitch. So it is 7 minus 5 for lap winding and 7 plus 7 for wave winding. So it is 2 and 14. So it is always 2 for a lap winding. So winding pitch is always 2 for a lap winding and commutator pitch is always 1 for a lap winding. So other things you have to calculate. And commutator pitch is the distance between two commutator segments to which two ends of the coil are connected. Start and finish of a coil are connected. Distance between two commutator segments to which two ends, start and finish of a coil connected. So for lap winding it is always 1. For wave winding we have to calculate. So it is start and finish of a coil are connected. Distance between two commutator segment to which start and finish of a coil are connected. Start of this coil 1 is connected to slot number 1. Finish is connected to 8. So it is 8 minus 1, 7. Okay, 7 for wave winding.